This is Article 3, the latest satellite coming out of NASA's JPL. It is called the Sentinel-6. The purpose of the Sentinel-6 mission is to get a better idea of how our oceans are changing and how that's going to affect humanity. So the Sentinel-6 has some really cool gadgets equipped to it that's going to be able to get a very accurate idea of what's happening at the sea surface level. Apparently, older satellites kind of give you like half the picture of what's going on. So the Sentinel-6 has a microwave radiometer that's getting an idea of the EM electromagnetic radiation that's bouncing off of the sea surface. And it also has a radar altimeter, which is getting the distance between the satellite and the ocean surface. So you're kind of getting data about the waves, and you're getting about like a heat map of what's going on and putting it together to get a pretty accurate idea of how our oceans are changing.
So let me get this right. This Freilich Sentinel-6 seems like a really complex machine, but what it comes down to is they really have two sensors on there that are the secret sauce. And one of them is the microwave radiometer, which tracks electromagnetic radiation. If you don't know, EM radiation is basically heat. So they're able to get a heat map of what's happening on the ocean. And the second sensor that they have on there is a radar altimeter, which allows them to track the height of the waves, the patterns of the waves. So between those two, do they get a complete picture of what's going on weather-wise at the coastline?
They do. The coastline is exactly the part that they were looking for, because previous imaging techniques and just measurement techniques don't really give you a big idea of what's going on, like a precise idea of what's going on at the coastlines. But these two together really fill in that picture. So, Dan, another thing that was actually interesting is that this satellite is going to take advantage of something called radio occultation. Basically, whenever the Sentinel-6 sees another satellite, usually a navigation satellite that we have tons and tons of in space, either below or above its horizontal, like with respect to Sentinel-6, it can either send a signal or receive a signal, and that signal will pass through the atmosphere. As it passes through the atmosphere, an effect happens called refraction, and the scientists are able to use this and backtrack using an algorithm to what the conditions in the atmosphere at that time were like. So we're talking temperature, moisture, atmospheric density, things like that.
Okay, that makes sense. So they've got multiple satellites in space, and once one of them dips below the horizon, past the curve of the Earth, and sorry, flat earthers, yes, the Earth is round. Once the other satellites dip below the curve of the Earth, they can shoot signals through there and measure how much they bend. Kind of like light bends through a prism. That's called refraction. They measure how much it bends, and that gives them an idea of the different qualities of the air inside the atmosphere.
You hit it right on the head. That's exactly what's going on.
Awesome.
So what's interesting about this, going back to the weather app, is that in the short term, this satellite is going to give us much more accurate weather data. But the real big mission here is to understand, they want to get a decade's worth of data about how our oceans are changing and how that's affecting us. So the Sentinel-6 actually has a sibling. It's going to do a decade-long mission, gather all this data, and come back so that not just NASA JPL, by the way, this is an international effort with the European Space Agency. They can get together, analyze what's going on, and talk about doing things to prevent further, damage to the oceans and the sea levels that are rising.
I think this is an awesome effort. So I am really excited about how in the short term we'll get more accurate weather forecasting from it, but also in the long term, between this satellite and its sister satellite, the two of them that go up will collect decades worth of data and give us an accurate picture of what's going on over time. Are the sea levels rising? How much are they rising due to global warming, and how will that impact human population moving forward? And a really, really important note that I think is cool to pick on there is, you mentioned it quickly, that it's an international effort. For such an important problem, it's exciting to me that we've got people from all over the world working on it.
Absolutely. Science knows no bounds. Our problems knows no bounds. It does not know state lines or nation lines. So it's good that we can all come together and work towards a single unified goal.